Okay, so now what we will see is there. What I'll do is, if this now what type of topology is this? This is an extended star topology, if you say, because a switch is connected to this switch like this. If we refer to our documents, we have seen topologies earlier. What type of topology are we creating? We are creating an extended star. One switch and n devices is a star. One switch, another switch, and extended star. Now what I will do here is I will assign these devices with IP addresses. For example, if I say these 4 devices will be assigned with IP addresses from the same network, 192.168.1.1. This I will assign 192.168.1.2. Same network, 192.168.1.3, 192.168.1.4. Now what we will do is, this orange belongs to orange VLAN, pink belongs to pinky VLAN. Now what happens is, 2 devices in the same VLAN will communicate. Now understand one thing, the moment a frame enters a switch port, it is tagged with the VLAN tag, you can say. If the switch sends out a frame, the tag is removed. I'm not talking about this one, but in a normal scenario, if the data is sent out to the end device, the tag is removed. So what will happen? Now if I say this switch has 2 VLANs, he sends his data to this switch. How will this switch understand which VLAN does the data belong, right? So what can be done over here? If you use this switch, will not be able to understand does the data belong to this VLAN or this VLAN, right? How will he take the forwarding filtering decision? Getting the point? So that is the reason the link that goes from a switch to switch is of a different type. This is known as a trunk link. A trunk link will carry the data of all the VLANs, and you can say a trunk link is a part of all VLANs. So anytime a frame is sent out on the trunk link, the VLAN tag is not going to be removed. So this is how the receiving switch will understand the VLAN of the data. He will say, okay, do you come from VLAN pink? Okay, you go to VLAN pink. If you come from VLAN orange, then you will go to VLAN orange only. This is how the switch will take the filtering decision, right? And this trunk also has a protocol. We'll discuss about dynamic trunking protocol later on, but let us do this small practical. Let us say these IP addresses 192.168.1.1, 192.168.1.2, 192.168.1.3, and 192.168.1.4. So even devices will be able to communicate with even devices. This device 1.1 will communicate with 1.3, even will communicate with even, 2 will communicate with 4, 1 will communicate with 3. Let us do that. Now by default everybody is in VLAN 1, right? So I will use VLAN 2 over here, I will use VLAN 3 over here. So VLAN 2 is pink, VLAN 3 is orange. Let us write the configuration, enable configure terminal. Now I will create a VLAN 2, name is pink, VLAN 3, name is orange, exit interface F0/1, switch port, mode, trunk, switch port, access VLAN 2, right? Exit interface F0/2, switch port, mode is trunk, sorry, I did shown is access, and switch port mode access, again switch port access VLAN 3, right? And on the interface that goes over there is a trunk interface, right? Interface F0/3, switch port mode is trunk. Actually we are supposed to decide the encapsulation first. Switch port trunk encapsulation dot 1q. Here we are supposed to specify this, but this is my latest switch. You can say he has only one type of encapsulation, or else if you are working, you have to say that command switch port trunk encapsulation dot 1q. You have to manually specify the encapsulation between those two devices. But as of now, it is not required in my scenario, but based on your scenario, you have to do that. So what I will do is simply I will take this configuration and push on my switch 1, and understand one thing, the same ports F0/1, F0/2 are here also. So if I paste the configuration on both the devices, it will just work fine. Let us see. But if you are in a different kind of scenario wherein you have different ports, be very careful with assigning the ports. But I suggest you don't follow copy pasting stuff, because it might not work out for you. Enable. Let us paste the configuration over here, and let us also paste the same configuration over here. Show interface trunk is the command to check the trunking. See here, the trunking mode is on. 802.1q is the trunking encapsulation. Trunking native VLAN is 1. I'll tell you what native VLAN is later on, but as of now, see, you can also filter which data passes through the trunk link. If you say, I do not want the data of VLAN 2 to be sent over on this trunk link, you can also do the filtering like that. You can say switch port trunk allowed VLAN 2. So he will only allow 2. You can say, if you say switch port trunk allowed VLAN, remove 2. He will remove 2 from the allowed VLANs. He will not allow VLAN 2's data to be propagated on the other switch. But as of now, we have to test, does even communicate with even and odd communicate with odd. So 1.1 will be able to communicate with 1.3 only. Let us see if the convergence has happened. 1.1 should communicate to whom? 192.168.1.2. Even though 1.1 and 1.2 are a part of same switch, they are connected to the same physical device, but they are logically separate. So the data goes from my device over here to the switch. Switch sees, oh, you belong to VLAN 2. I cannot send you on the VLAN 3, but I have one interface that is trunk link. So he belongs to all VLANs. I will push it over here. This switch receives the data from VLAN 2. He says, okay, VLAN 2 tag, you can go only on this side. And this guy is the one who sends us a reply back. Like this. Let's go and check. 1.3 gave us a reply. 1.4 will also not give us a reply. Let us go on the even device. Let's go on 1.2 and let us ping 192.168.1.4. Yes, technically you will have a separate IP subnet. That is a very good practice, but we are in a testing scenario, so we can give any IP addresses. But usually one VLAN has one IP subnet. So it becomes very easy for us to troubleshoot, and implementation is also good. So this here completes the basic configuration of creating VLANs, assign ports to the VLANs, and creating a basic trunk interface. Also note down one more very important command. You can say show interface F0/1 switch port. This is a very good command. You can see a lot of things in this command. Show interface F0/1 switch port. This tells you the name. This tells you it is enabled, what is the administrative mode and what is the operational mode. Now this is trunking encapsulation optional native VLAN, and this belongs to VLAN 2. And as of now, so you can gather a lot of data from here also. Getting the point?
Yeah.
What if you say, I want this guy to communicate with this guy? If you say, I want this VLAN to communicate with this people in this VLAN to communicate with this VLAN, it is not possible using a layer 2 switch. No, he will never allow this to happen. But if you want to do this, you have to take the help of a layer 3 device. Then we will do something called inter VLAN routing using a layer 3 device. Getting the point? Okay, let's come back after the break and let's do that.